So we are going to move on now to section 11.2. And so we're going to talk about odds. So if you have ever seen any type of gambling or sports betting or things like that, you're often going to see odds, and that determines payouts for different things. So like the odds of this person winning the fight are like 75 to like 52, some random numbers a lot of times. And so that gives you a pay scale because the odds are in favor for someone else, or the odds are stacked against this person. So if you bet against the weakling or the person that's less likely to win, then you're going to have a better payout overall. And so what we're going to do today is kind of work on what that actually means and how to calculate the odds in favor or against some event happening. So really, they're closely related. They're just the flip of one another. But the odds against an event is the ratio that the event will fail to occur to the probability the event will occur. Okay. So ultimately, if you want the odds against an event, it's going to equal the probability the event fails to occur divided by the probability the event occurs. So another way you can think of this is failure up in the top, so the probability of failure divided by the probability of success. And apologies, my dog is playing in the blinds for some reason and just running around in circles. What are you doing, silly? Come here. Go lay down. Go lay down. Come on. Go down. Go lay down. Yes, how beautiful. No, you don't get to eat my pen. When we deal with probability in or odds in favor, we're just going to flip that. So success is going to go in the numerator, failure in the denominator. So let's try an example. Let's determine the odds against the event. And so we'll do two examples. We'll determine the odds against rolling a 4 on a standard die. Okay. So the success of the event is that you roll a 4. So when the event fails to occur, you don't roll a 4. So our probability of success is the probability of rolling a 4. That's the event being successful. You have a 1 in 6 chance of that happening. Okay. And this is going to split your thing into two distinct events. It's kind of like the probability of A, the probability of not A. You roll a 4, you're successful. You don't roll a 4, it's a failure. So our probability of failure is the probability of not rolling a 4. So when it gets more complicated, you could just say there's 5 out of 6 numbers. Really, you take 1 and subtract the probability of that event occurring. So you have a 5 in 6 chance of a failure. So the odds against rolling a 4 are going to be our probability of success, probability of failure, divided by probability of success. And our failure is a 5 out of 6. Our success is a 1 out of 6. So we can go ahead and simplify this. I'm taking this first fraction, dividing it by 1 over 6. So it's the same thing as multiplying by that reciprocal. So really, the 6's cancel out. And I don't want to just write 5. We're going to write 5 over 1. Okay. because our odds are 5 to 1. So the odds against rolling a 4 are 5 to 1. Okay? So it's stacked in your favor that you're not going to roll a 4. So ultimately, if you're betting that you're not going to roll a 4, you're not going to get as good of a payout as if you bet towards rolling a 4, because the likelihood of that happening is smaller. So let's try one more of these, and then we'll do odds in favor. Let's do the odds against selecting a king from a deck of cards. Okay. So we need to find that success, we need to find that failure. So our probability we're successful is we do indeed get a king. So there is a 4 out of 52 chance we get a king from a deck. And we're going to simplify this. So divide top and bottom by 4. We have that 1 in 13 chance of drawing a king. Our failure is going to be we don't get a king, which again is 1 minus the probability of drawing the king. Because either that you're successful or you fail. So once you find one probability, you've got the other. So this is 1 minus 1 over 13. You have a 12 in 13 chance of getting something other than a king. Okay. So every single time when you're dealing with these odds, your success and failure better add up to 1. So 1/6 plus 5/6 is 1. 1/13 plus 12 over 13 going to be 1. If you notice, when you add up the numerators, it's exactly the denominator that disappears. When you add up the numerators, it's 13, which that 13 is going to disappear in our fraction for the odds against. So the odds against a king are going to be our probability of failure divided by our probability of success So that's 12 over 13 divided by 1 over 13. And again, you're taking 12 over 13, dividing by a fraction. So you multiply by the reciprocal, and that 13 ends up canceling. So you get 12 over 1. So the odds against a king are 12 to 1. And 12 plus 1 gives you 13, which is the denominator of our probability. We're going to need that very soon. Now the odds in favor is super simple. Flip it. So the odds in favor of an event is as follows. This is going to be success in the numerator and failure in the denominator. So just the flip. So it is the probability an event occurs. I'll try to flip when you get a pencil in your hand over the probability the event fails to occur. So really, once you have one, you've got the other. You just switch that fraction. So if we take these exact examples from the prior example, for part A, the odds in favor of rolling a 4 would be, we go back up here, we literally just flip these, so the fraction is going to flip. So the odds in favor of rolling a 4 are 1 over 5. Or you have a 1 to 5 chance of rolling a 4. The odds in favor of selecting a king are the exact flip here. So we just change these two. You have a 1/12 or 1 to 12 chance of getting a king. Okay. All right. So this is really the bulk of this section. Really have just some more examples that we're going to go through. And then we'll do one where we're given the odds. We want to reverse engineer those probabilities. So that's where it's going to come into play that every single time these two add up to the denominator. So these two, 5 to 1 for rolling a 4, add them together, it's your denominator, which is a 6. So we want to go through and utilize that. But first, let's try 2 examples to get more practice computing probabilities as well. We're told one marble is selected at random from a box of 12 blue marbles and 16 red marbles. We want to determine the odds first against selecting a red marble. Okay. And we do want to simplify it as much as possible. So first, we need to determine our probability that we're successful. And so it's against a red marble. That would mean our success of the event would be we get a red. So we've got 16 red marbles out of a total of 12 plus 16, or 28 marbles. So this here is the total number of marbles. So really, you have a 16 out of 28 chance of getting a red marble. And these are both divisible by 4. So that's really a 4 in 7 chance that you're going to have a red marble. Okay. Our failure is going to be the probability that the event fails to occur. So we fail to get a red marble. Couldn't think of the word there for a minute. So the probability of failure is the probability of not getting a red marble, which is 1 minus the probability we get a red marble, because you get a red or you don't. So it's 1 minus 4/7, which would be 3 out of 7 when you simplify it. Hey, stop. Off. So we have a 3 in 7 chance of not getting red, which you could also find by saying you have a 12 out of 28 chance of not getting red. So now that we've got our 2 pieces, the odds against a red marble are going to be our probability of failure divided by our probability of success. So that is 3/7 divided by 4/7. And again, we flip that bottom fraction in the division, causes these 7s to cancel, and we're left with 3/4. So the odds against red are 3 to 4. Right. Now we'll do one more. We could do the odds in favor of selecting a red, but instead I'm going to do the odds in favor of selecting blue. Which is really the same thing as the odds against selecting red, because if you don't select red, you're going to select blue. So that's our same really like thing. So we want our success to be the probability of getting blue, and our failure is the probability of not blue, which again is 1 minus the probability of getting a blue marble. So the probability of us drawing blue is 12 marbles out of a total 28 again. So our probability of success is 12 over 12 plus 16. So 12 over 28. And we can simplify this, divide top and bottom by 4. That is 3 over 7. Okay. So our probability of failure is 1 minus 3 over 7, which is 4 over 7. So again, add these two together, gives you 7 out of 7. So the odds in favor of blue are going to be probability of success over the probability of failure. So that's 3 over 7 divided by 4 over 7, which is really exactly what we did last time. Again, the numerators just say this becomes 3 over 4. So the odds in favor of blue are 3 to 4. Okay. So really, you don't need that denominator every single time. It's going to cancel as long as you simplify everything ahead of time. But again, it's going to help us reverse engineer because those two values added to the denominator that cancels. All right. Let's try one more of these. We're given some information about smartphone ownership. Okay. And so people have a bunch of different smartphones with some percentage of likelihood that they own it. So based on this survey of data, 42% of people own Apple. 27% of people own Samsung. 7%, and this is going to be exaggerated to fit stuff in, 7% of people own LG. 6% own Motorola. 5% own HTC. And then just other brands, 13% of people own. Okay. So based off of all these percentages or probabilities, the first thing we want to do is determine the odds against the individual owning a Samsung phone. Okay. So we've got percentages, we want to turn them into probabilities. So in total, there's 100%. So our probability of success is the probability that the person owns a Samsung. 27% of people do. So this is 27 out of 100. Our probability of failure is the probability the person does not own a Samsung. Which you could totally add up all the percentages over here. But again, 27% of people own Samsung. That would mean 1 minus, or 100 minus 27, or 73% of people don't own one. So this is 1 minus the probability they indeed own a Samsung, which is 1 minus 27%. So 27 out of 100, which means 73% of people do not own a Samsung. Okay. And so the odds against a Samsung are going to be our probability of failure divided by our probability of success. So that is 73 out of 100 divided by 27 out of 100, which you don't need to keep doing this. Those denominators cancel. You get 73 over 27. So the odds in favor are 73 to 27. Okay. And again, these two values add up to 100, which is exactly what our denominator is. That cancels out. So the probability of a Samsung is 73 divided by the sum, not a Samsung, or sorry, probability of not a Samsung is 73 out of their sum. Probability of owning a Samsung is 27 out of the sum of those. So let's try one more of these. And then I have one last example in this section, and that will be a good place to stop here for the day. So let's try to determine the odds in favor of owning an LG phone. Okay. So I'm no longer going to write success and failure. I'm going to just write probability of an LG, probability of not LG. 7% of people own an LG phone. So our probability we're successful is 7 out of 100. The probability of not an LG is 1 minus the probability of LG. So you have a 93 out of 100 chance that a person does not own an LG phone. So the odds in favor of the LG are going to be 7 out of 100 divided by 93 out of 100. Those denominators will cancel, and we're left with 7 over 93. So there's a 7 to 93 chance in favor of owning an LG. Okay. So just as some kind of notes of stuff that I've reiterated, the first one, the denominator will cancel when simplifying our odds. And the second, the denominator, is the sum of the two odds, or the two components of our odds. Miss Macy, hey. So this observation is going to help us in our next example and when we have to reverse engineer. Okay. And our third observation is that our probability of success plus our probability of failure should always equal 1. So you can always double check yourself. Okay. So let's try one last example, and then we will be done with section 11.2. We're told the odds in favor of Shelby winning the lottery are 7 to 11. So we want to determine the probability that first Shelby wins the lottery. Okay. And then we're going to look at her probability she doesn't. But dissecting this 7 to 11, that's representing 7 over 11. This is the odds in favor. So this is considered our success. So that would mean she wins the lottery. And the denominator would be failure. So this would be she doesn't win. Okay. So I've got just the numerator of each of those probabilities. So the denominator of the probability of success slash the probability of failure must be 7 plus 11. So that the denominator can cancel out in the odds. And make the sum of each one. Make the sum of the probabilities 1. Okay. So ultimately, our probability of success is the probability Shelby wins the lottery. The 7 is what deals with our winning because it's the odds in favor. And our denominator should be 7 plus 11. So she has a 7 in 18 chance of winning the lottery. If we try to figure out the probability that Shelby doesn't win the lottery, we're just going to use that failure from the bottom. So the probability of failure is the probability she doesn't win. So you have 11 out of their sum. So you have 11 in 18 chance. Okay. So this way now you can kind of take a look back and verify that things worked out correct. So if I look at the probability of success divided by the probability of failure, it's 7 over 18 divided by 11 over 18, which is 7 over 11, which is exactly what we started with. That was our odds in favor of winning the lottery. The other thing you can notice is she's got to do one of two things. She's got to be successful or she's got to fail. So if I go ahead and add up the probability of her being successful, plus the probability of her failing, it's 7 over 18 plus 11 over 18, which is 18 over 18. She has a 100% chance of doing one of these two things, which is what better happen.